Welcome to PerceptiLabs' first live stream where I code. And so for this coding session, I'm going to build a handwritten, sorry, not a handwritten image classification model. That's what I usually build. I'll be building a model which recognizes sign language. So you can get the sign language dataset on Kaggle fairly simply. I'll see if I can pull up the dataset here. So you can get this one, and it's not this one. I'll link it later on to which one it is. But it's the early used Kaggle dataset, and I figure we will just try to build a model which recognizes it. And the gist of it is that you have 10 different digits in sign language. So somewhat similar to MNIST. So we can start with just trying if an MNIST model would work and how well we go from there. So I'm not going to introduce the tool too much in itself. I'll talk a little bit about it as we go, but we have plenty of videos on the YouTube channel as well for it, if you're interested in how the tool itself works. But before I start with the model, I'll just create an empty template. So you have something to go from. And I have already prepared a dataset for it, or I downloaded it. And the one thing you need to note with the dataset is that you probably want to randomize it before putting it into PerceptiLabs. Otherwise, you'll have groups of, for example, all the nines of the digits comes at the very end, and that just happens also to be the testing data set. So you'll just train on the first 7 digits, then you'll validate on 8 and 9, and then you'll test on 10 or 0, which essentially means that you're not training it properly. So I have 2 data sets here, which have already been shuffled. One for X, which is the hand itself, and then one for labels, so input and labels. And after loading this dataset, the first thing we can see is that we don't have a last channel in it. So I'm just quickly going to add a reshape tool to it and make sure we have the right dimensions. So we get that last channel in. Otherwise, TensorFlow or PerceptiLabs will start confusing the different dimensions with each other, and it will start thinking that this 64 is actually a last dimension, which will make any convolution you apply to it act as a one-dimensional convolution instead of a two-dimensional one. So if we're going to start with trying just a normal image classification, the same way I have in a template, I would just be adding in a convolutional component and then a dense component. And usually you don't have any activation function at the end. We can try with none and see how well that works. Sigmoid is often a good one, just to get some adjustments at the end as well. Let's see how that works. And we already have, we don't need any one-hot encoding on this dataset. It's already been done in pre-processing. And since it's a classification problem, I'll be using a classification training component. All right, and in the training component, I think we can go as this to start with and see how well it works, and then I'll start playing around with the learning rate or the number of epochs we train. But let's just do a test run on this and see what kind of accuracy we end up with. Alright, maybe not the best start, it's oscillating a bit. And we can see if it learns anything. It does have gradients, so it's training or trying to train something. So when it's oscillating like this, it usually means that it's trying to take 2 large steps of learning, which oftentimes means either your learning rate is wrong or you don't have enough complexity in your model, so there is not enough components for it to learn, and it just learns a small piece of it and can't learn on the rest of it. So we can try by starting making the model a bit larger, adding some more parameters to it, and then see where we go from there. I can also see the loss the loss looks somewhat okay. It goes down. I mean, it kind of stays down, but at least it drops at the start. So let's try adding in a few more feature maps and see if that can help us. And maybe we'll add another dense component in between. There we go. Let's bump this one up. Alright, let's try running that. I don't think we want to use the weights from the last session. It's probably going to take a while longer to train now when we added a bunch more complexity to it, but let's see how the shape of the accuracy and loss looks like for a while before we decide to abort or keep training on it. We can also see the gradients died out very quickly, so we're probably not going to get too much luck on this one. Although the loss does look fairly good. Okay, I don't think we're getting much further with this one. As you can see, the prediction is changing. We can let it train for a little bit longer and see if it gets more into shape. So what you preferably want from looking at the accuracy and loss is that you want a loss which gradually decreases, which this one does, and then doesn't start oscillating too much at the end where it goes up and down, because that essentially means that it can't find a local minima, it can't find any good model, and it'll try just going back and forth between 2 bad ones, essentially, or multiple bad ones. And for the accuracy, you want a nice curve pointing upwards, which at some point is going to die off. But when it looks like this, it's essentially just randomizing. Sorry, not randomizing, it's essentially just getting random values. And from what you can see here as well, it's not really certain on anything. So I think we might have added too much complexity to it. Got a question, what happens if we run several models at the same time? We can do that. We just open a new template and we just all run in parallel. I probably not going to do that on this laptop while streaming. I don't know if the little notification I got before said that it was already using a lot of memory. So I would have to boot it up on a cluster around the Docker version for that to run better. But running multiple models at the same time would be a great way to try out different types and see how they worked without having to go back and forth like I'm doing now. So if a dense component was too much complexity, let's try removing that one and adding another convolution component instead. See if that one processes the image a bit better. Here we can see the auto settings in play as well, where it automatically got the right amount of, or a good amount at least, of feature maps. I think we want to bump that down maybe a little bit again. See how this one works, and I think I'm gonna take the softmax back here. Always had better luck with it. Alright, hopefully this one would run a bit faster, since it's not as heavy as a dense component is, and hopefully it also performs a bit better. There we go, running a lot faster. We're not getting any decent predictions at all though. Looks like they're all 0. And the accuracy and loss look very died out. Okay, so let's go back and try reducing the complexity a bit more. We know we're gonna need Tenet here, but we can keep iterating on the feature maps until we get something which works decently. Another thing we can try out is changing the activation functions. So I just have it on sigmoid now. We could try something like the tan or ReLU on some of them and see how that one works. This one's usually better, better performing in many cases. Let's try something like that. Okay, we have the prediction back. That's a good start, and it's looking a lot better. Now I'm not sure if it was the change in the activation function which did it, or in the complexity. We can try out and see what actually happened. But we now have something which looks like it's learning a lot better. You can see that we go up to about 70%, close to 100% for the training at least, of the accuracy. And if we run the test, we should be able to see if it actually performs well here also, or if it was just the validation and training. So it's a bit uncertain about that one. What I'm just doing here is going through the different samples and seeing if it actually predicts correctly, to see if they didn't overfit on the training or showed wrong on the validation in the statistics window. I can see here a 5 looks like a 5. And I wouldn't guess this was a 9, but it seems like it is, and the model can see it pretty well. So let's go back and see what actually did that. If it was the activation function or if it was the complexity of the model. So if you just change this back but keep the same complexity and then run it. Then it's all 0 predictions again. So it definitely looks like there was something with the activation function there which did it. Alright, so we have a good base. Let's see if we can improve a bit on it as well. Can try removing that activation function from this one and see if that helps. As I said, normally the last layer in a neural network doesn't have an activation function because it's extra complexity for the model to learn unnecessarily. Yes, the output of it is usually enough, but sometimes these things do magic. So it's looking decent-ish here. It looks sometimes okay. Accuracy is looking fine, except from validation where it's constant 30-40%. Something's up with the validation here. The accuracy seems great. Or the training accuracy is great, but not the validation one so much. Let's see how it performs in the test. Another question also, if we can run PerceptiLabs with Colab. And yeah, there is at least one way you can do it, which is fairly simple, that if you have a model, you can just export it, and you have a choice here to export it as a notebook. And if you do that, you can spin up that notebook inside of Colab. Then you can also technically run PerceptiLabs in Colab, just start the tool itself, but there is there's a collision currently with the different ports, which we're looking into right now. So I think this way definitely will work. If you try running it in Colab, it may work for you. It may also collide with the different ports. Okay, you can see here it definitely is not as good. Another question, if it's mostly for modeling or if you actually can run them in production. You can definitely run them in production. It's the tool is to help a lot with the modeling and give visibility into your model. But when you export them, they are ready to go for production. And we recently did a collaboration with Coral, Google Coral, which you should see sometime soon, next week maybe or so, where we did just that. We exported and we used it on a Coral card for production. And then you just use the compressed version of it instead. So it's they're definitely the tool is built to be able to quickly iterate and take the models into production. That's kind of the end goal with it. Let me know if there was any specific production you were thinking about. Maybe I can give a use case. Back to the model though, we definitely want sigmoid on this one. And I'm kind of curious what happens if we just increase the complexity a bit more. See if we can get a little bit better predictions. If you're wondering why I'm looking down to the left all the time, it's because I have the comments in the phone there in that second screen at some points. Alright, this one seems to perform a lot better. At least a lot better than the previous one. Although the validation is still stuck at 50%. Seems to be predicting pretty well though. I got a fairly decent training accuracy as well. The training accuracy here does say 100%. I think it's just taking the last value. So if you want an average training accuracy instead, we're putting that in the tool as well, but for now you can estimate it by looking at about how high this one is. So it's definitely over 90-ish%, which does perform fairly well. So we can try playing around with this accuracy or this complexity a bit more. I don't think it will give too much more. We already have a fairly working model. For fun's sake though, I kind of want to try to see what happens if with the different optimizers. So we're currently using an ADAM optimizer, and the optimizer is it's what trains the tool. How the training works is it compares these two, and then it calculates something called a loss function, which is what we see over here. And this loss function is an estimate on how well trained the model is. Then it uses this loss function and updates the parameters or the weights in these components according to what the loss was. So a few good ways to try different types of models and try training them in other ways is to try different loss functions and different optimizers. The optimizers are fairly standard ones. The loss function though you can customize quite a lot, and there are a few problems where you do need to completely customize it yourself to make sure that it fits your problem better. Then the learning rate down here is just how quickly it updates or how quick steps it takes in each update. So let's try, with that said, the optimizer, since it trained fairly well, the optimizer might be good. So let's try as a different loss function instead for fun. like the cross entropy, for example, and see if that one does any difference. That's a difference. It seems like TensorFlow did not like the cross entropy on this one. It might be that cross entropy has an input already, so you can't use activation function with cross entropy function. So let's try going back to quadratic and instead playing around with some of the different values. So increasing the batch size both increases how quickly it trains, but it also increases since it trains on an entire batch instead of alright. I think my computer is starting to complain a bit about streaming at the same time as training. So maybe not increasing the batch size while streaming. Again, another good point for why to run this as a Docker version in the cloud instead of just on a local CPU. Let's see, another question. So how to add your own loss function? So currently each component acts as a template for these settings for code. So you can very easily just go into the code and customize anything yourself. So if you want a loss function, for example, it's right here. And in this case, it's a very simple just reduce mean, square root, essentially, of the output subtracted by the target. But if you want to customize this one, you can just add something in here yourself. The custom components then are great for building. Say that you wanted a special activation function between them and you wanted it visible. Then you could very simply just plop down a custom component and open the code here, and anything you write in here or anything you set as the y value, that will be the output of the component. We are looking to split this one up a bit though. So one idea was to put the optimizer and the loss function as their own components outside of the training component. Just so it's a bit more visible what happens inside it. Let's try a different learning rate and see if my laptop wants to survive that. Let's see, another question about the tests. Can you run the complete test set at once or only one test sample? Dane already gave a good explanation for that one. Alright. Well, I think that's as far as we go with the streaming software on this model. But we did get a fairly good model at the end, which around 90% accuracy. That's not so bad. And we do have I'm not sure if it's exactly this model, but we do have another template as well, which our intern built a while ago, which is similar in case you want, and it's available on our GitHub if you want to try something like this yourself and just play around with a similar architecture. Okay, another question is if there will be a future option for different ML libraries. And Dane already answered that fairly well with possibly PyTorch at some point. We're currently right now going with TensorFlow, and we're about to upgrade to TensorFlow 2.x as well. Right now we're running on TensorFlow 1.15. But the kernel itself is fairly open. And thanks to that, we are looking to further down the line implement things like PyTorch. If you just want to use different libraries in the tool though, again, it's available through the code here. You can just write a normal import. Anything in this code acts like normal Python code or a normal notebook. So you could very easily play around with different libraries and how to handle in different components. Would it be possible to insert hyperparameter tuning in the code directly and run it from PerceptiLabs? Yeah, absolutely. You can put that in the training component, or depending on which hyperparameter library you're using, or in the different settings in these different components. And then when it would run, you would still see visualizations and everything, but it would just run with the hyperparameter tuning tagged onto it. Another thing we're looking to do is to create a visual part for that one as well, so you could use the visual interface to play around with hyperparameter tuning also. Okay, but that was all of the stream which I had planned for now, just showcasing this model. If anyone has any last questions, I'll be glad to ask them, and feel free to join our forum or Slack if you want to ask me at any point afterwards. But I'll stay in the chat for another 2 minutes or so, if anything pops up. But thanks a lot for watching, and I hope you learned something. Have a great day or evening, wherever you guys are.